Hi, today we are going to model solving two-step equations. Our goal for today is to use the properties of equality to solve two-step equations. So we're going to do some practicing in our heads. If I had something here, what would this have to equal? What's under the block? If this number plus 3 equals 15. What's under the block would have to equal 12, right? Well, now if I say that 2 times x is under the box, we know this has, sorry, I moved too quick. We know that this has to equal 12, so 2 times what equals 12? And that's 6. So sometimes covering up the variable can help you solve equations in your head. Oops, now I have my answer there. In this case, I have 8 equals some mystery number minus 1. Well, that mystery number has to be 9. But if I had 3x here, then I know this has to equal 9. 3 times what equals 9? X would have to be 3. Okay, now let's practice showing how our steps work. I'm going to first, you recall we always talked about having a party and sending people home. Here's you, you're the X. The X is what we need to get a loan. So who are we sending home? Sorry. Who are we sending home first? We got to get rid of this plus 3 first. Those are our acquaintances. Remember, our best friends are the ones closest to us. We got to send home our acquaintances first. So how do we send home a plus 3? With a minus 3. So I have to subtract 3 from both sides, because what you do to one side, you have to do to the other. So 15 minus 3 is 12. 3 minus 3 is 0, so this cancels out, and I'm just left with 2x on this side. My x is not by itself yet. It still has that 2 attached to it. It's two closest friends, so we got to send those home. How do we send those home? Through division. Since that's multiplication, we divide. It's just a one-step equation at this point. 12 divided by 2 is 6. And my 2's cancel here because 2 divided by 2 is 1. And I'm left with 1x, or x. Excuse me. Got a tickle my throat. So let's move on to our next one. I have 8 equals 3x minus 1. I'm going to send home my minus 1 first. Opposite of subtracting 1 is adding 1. So I need to add 1 to both sides. This will cancel out. Minus 1 plus 1 makes 0. I'm left with 3x. 8 plus 1 is 9. My x still is not by itself. I have to get rid of that 3 that's stuck to it through that invisible multiplication. So the opposite of multiplying is dividing. I'm going to divide both sides by 3. And x will equal 9 divided by 3, which is 3. Okay, I have another problem now. This is example, well, it says examples 1 through 7. I need to get rid of this minus 3. So we will add 3 to both sides. Because again, my goal is to get my n by itself. Minus 3 plus 3, those are opposite, so they cancel to 0. I'm left with n divided by 2, or n over 2, equals 5 plus 3, or 8. Not done yet. My n still is being divided by 2. The opposite of division is multiplication. So I'm going to multiply both sides by 2. And I get 16 on this side. This cancels with this, and I'm left with n. N equals 16. I do encourage you to check your answers. You don't have to do a full out writing it down, but if I put a 16 here, 16 divided by 2 is 8. 8 minus 3 is 5. Just really a good habit to check to make sure that you didn't make any mistakes along the way. Next example, number 2. My goal is to get the y by itself. So I need to get rid of first my minus 5. Get rid of that. I will add 5 to both sides. This will cancel out, and I'm left with 1/3 y equals, that is a wacky y, negative 5. I have to fix that y. Negative 10 plus 5, negative 5. Okay, remember when we have a variable attached to a fraction, we will multiply by the reciprocal to get rid of it. So the reciprocal of 1 over 3 is 3 over 1, just plain 3. This will cancel out. I'm left with y equals negative 5 times 3 is negative 15. Let's do a quick mental check. 1/3 of negative 15. Well, 1/3 of 15 is 5, so that would be negative 5. Negative 5 minus 5 brings me to negative 10. So I did it right. Example 3. 8 minus t equals 3. We've seen some like this before. Remember, we have an invisible 1 here in front of that t. That might help us solve it. We need to get this t all by itself. First, let's send home our acquaintances, which is the 8. I need to subtract 8 from both sides. If I added 8, I would end up with 16. I want it to go away. I need to subtract 8. Now this is gone. This is gone. 3 minus 8 is negative 5. But what's left over here? I still have that negative 1t or negative t. I'm going to write the 1. That's optional. Just might help you with how you think about it. So to get rid of this, I need to do the opposite, which is divide by negative 1. The inverse of multiplication is division, so divide by negative 1. Both my negative will cancel, and so I'm left with 1t. And negative 5 divided by negative 1 is positive 5. So if I put a positive 5 up here where this t is 8 minus 5, 3? Sure is. Next example. When we start getting some of these, it's very easy to confuse students because in most of them we are adding and subtracting first. But in this case, these numbers are closer together than the 4. Or you can think of it as like these are in parentheses. You have to do these together. So I need to get rid of this 4 first. To do that, I will multiply both sides by 4. My 4's will cancel out. I'm just left with x minus 2 equals 24. Still have to get rid of that minus 2, so I will add 2 to both sides. And x will be equal to 26. Now, if I put a 26 up here, 26 minus 2 is 24. 24 divided by 4 is 6. So it does work. I did not clear my screen. Same with this one. I need to get rid of this 3 first because my n is up here with the 7. So I'm going to multiply both sides by 3. 3 times negative 4, negative 12. This 3 and this 3 cancel, which leaves me with just n plus 7. Let's subtract 7 from both sides. This cancels, leaving me with n equals negative 19. Again, if you did a quick check, negative 19 plus 7 is a negative 12. Negative 12 divided by 3 is negative 4. Second to the last example, number 6 of 7. My goal is to get this c by itself, just as always. I'm going to isolate my variable. Stuck here by multiplication, this is the closest one, so we want to get rid of this 15 first. Let's subtract 15 from both sides. Students often see this minus, so try to add 15. The minus goes with the 5c, not with 15. This is a positive 15. Positive sign is just not visible. So I'm going to subtract 15 here also. This cancels out. 39 minus 15 is 24. And what is left over here? I have negative 5c. Don't lose that negative. That's where you get into trouble. So now to get rid of that negative 5, I need to divide both sides by negative 5. Now if you use a calculator, did log division, whatever, you could get this to a decimal answer. But I'm okay with you keeping it as a fraction. I do like when you have a negative that you pull it up to the front, and I end up with 24 over 5. Because if you think about this, I have a positive number, I'm divided by a negative, so my solution should be negative. Last example, and again, I forgot to clear my screen. School selling granola bars to raise money. They purchased 1,250 granola bars and paid a delivery fee of $25. The total cost, including the delivery fee, was $800. What was the cost of each granola bar? Well, they bought 1,250 granola bars for some mysterious number that we don't know. When we don't know that number, that's going to be our variable, x. So the cost of each granola bar times the 1,250 granola bars will tell us how much the granola bars cost. Then we also paid this delivery fee of $25. And our total cost, including that $25 delivery fee, was $800. So how much did each granola bar cost? Well, I'm going to need to subtract 25 from both sides because it's a two-step equation. I didn't draw my lines down like I normally do. I'm going to do that. My delivery fee cancels out. I'm left with $1,250 times X, or times how many granola bars there are, will equal 775. These are pretty cheap granola bars. They're going to be less than $1 each. So next, I need to divide both sides by 1250. 1,250 divided by 1,250. And assuming I did my calculating correct, each granola bar is 0.62 or 62 cents. A good deal for granola bars. That is it for our notes for today. Have a good time. If you have questions, you know where to find me.